be the instructor for this course. I'm really kind of excited to get going on this adventure with you. I will say, Stephen told a little bit of my background. I'm an economist by training. I kind of finished my dissertation research and all of that using Stata and SAS and MATLAB and all of these very, very expensive proprietary software systems. I think they have lots of great things. I'm not going to say anything bad about any of those, sort of softwares. But one of the things that happened over time is I really got more interested in sort of working with some of these open source environments. So obviously I'm teaching this course. I am an R user. I'm also a Python user. And so I've largely replaced Stata and MATLAB with R and Python, just depending on the tool. And I think it can be really great. And again, not to sort of be critical of any software. I mean, I think Power BI is a really nice thing. I think some of these are nice products, but I also think it's really great to be able to integrate perhaps your econometric models or forecasting models or statistical models in R, with some of these dashboards and do it without having to rely on, oh, my license expired or anything like that. So I'm really excited because you can do everything that we're going to do in this class. Let me get started here. I'm really, hopefully this will come across and you'll feel comfortable asking questions. But I really think these are great. I think there's a lot of uses, and I've certainly, since learning to do it, kind of what was I going to say? I've started using it a lot. So without any further ado, here we go. We'll get running here. There. All right. Interactive visual dashboards with R Shiny, day one. Here we go. Okay. So I know I put these in as what was I going to say, is incremental reveals, but let me just kind of put it all up at once and just talk about each of these things. So this is kind of an outline of where we're going. So we're going to review data manipulation and plotting. I will do a little bit of live stuff today, and I can always save it and then upload it to the Google Drive later on. Again, with like things like the apps and all that, I've pre-planned them all out, and so they're up there. But certainly things as we do can be put up there as well. Okay, so we'll start with a review of data manipulation and plotting, primarily using a ggplot2. That's certainly not the only one that's out there, and Shiny is not married to ggplot2. So if you have something else, you have something that you've done in base R and you want to keep it, or you've got some heat map that you really like from a lattice framework, you can keep that. There's no problem. I just am going to rely on ggplot2 for some reasons we'll talk about. So we're going to start simple with a flex dashboard. This is not sort of exclusively true, but typically things on these slides that appear sort of like in a bold, slightly different font, these refer to sort of names in R that I'm kind of purposely highlighting, that's how you would type it or how you would reference it. So we'll start simple today with a flex dashboard. And then we'll build more advanced dashboards using Shiny. You can use Shiny with a flex dashboard, but we're not going to get to that yet. Shiny is kind of going to kick off, like, what is Shiny? How's it frameworked? That'll all kind of probably be tomorrow or potentially the end of class today. We'll learn how to customize Shiny dashboards. We'll talk about reactivity and interactivity. We'll talk about changing colors and themes. We'll talk about maybe adding a logo. To be honest, it doesn't take much to make your dashboard look somewhat professional by adding, say, your company logo or your university logo or college logo or things like that. So we'll look at some examples of that and how it can customize and really make the appearance look nice and professional for us. And then we'll deploy our dashboard using shinyapps.io. Including talking about how to password protect, which for some situations might be pretty useful, not only to just keep sort of a random person off, but for example, you may be doing some plots that deal with some sort of proprietary data or data that needs to be protected. So we'll talk about some of the ways to do that. I'll show you what I think is sort of like the most, I don't want to say the most basic, but kind of the easiest way to incorporate. And I also briefly mention some alternatives to shinyapps.io. But we'll do it. I mean, I'll literally, it's on slides, but I'll literally do it live, and you'll get to see kind of the whole process go. Again, you'll have all this code. You can do all these things yourself. Okay. So today we're going to start with a review of basic plotting capabilities in ggplot2, and then we'll start into this flex dashboard, which I think is a really actually handy tool and a really nice place to start learning about some of these things and start thinking about it. It doesn't have maybe quite the capability or the features that we are going to see starting tomorrow, but it's a really good place to start. And in some situations, it may be all that you need. I don't talk about it in these slides per se, but the shinyapps.io, we could host a flex dashboard as well. So this could be distributed, or you can handle it other ways. Okay. So if we have time permitting, we'll start in on what is Shiny and what elements do Shiny apps have and some of the terminology and get that all rolling. That'll be sort of the main focus of I was about to say Tuesday, today's Tuesday, of Wednesday's session. Okay. So review of plotting in R. And just as kind of a comment here, I will be toggling between, you can see my RStudio window here that I already have up. I've already set the session directory to where I have some of the data. So you can see I'm going to type dir to show you what's in my current directory. And you'll see I've got some files here, but I've got CSV files. I guess this is an Excel file. But we've got some files that we can deal with. Okay, so I will be sort of toggling back and forth between these slides and actually sort of doing some things kind of like live in the code. Okay, so ggplot2. So as you can see up here with the bullet point, I don't really want to read slides to you, but you can see on the bullet point, integration with the Tidyverse makes it the go-to library for most data science applications. If you're not necessarily sort of familiar with the Tidyverse, I mean, this is Tidyverse, so tidyverse.org. There's actually a link at the bottom of the previous slide. There's a hyperlink if you wanted to, or actually, I'm sorry, the word Tidyverse was a hyperlink, so you could open this if you really wanted to. But you can just sort of see the description. R packages for data science. It's designed for data science. Packages share an underlying design philosophy, grammar, data structures, and you can install all of them with that, or you can do sort of individually. ggplot2, where my cursor is one of them. Now we'll talk a little bit about dplyr. So may look weird to pronounce, but you can see the picture is a plier. So it's a D and then funny spelled plier, so dplyr. Tibble, this is a sort of an alternative format to a traditional data frame. It is a data frame, but they just store things differently to be more efficient for memory. Readr is a way to import data sort of directly as Tibbles. String, this has to do with strings like, you know, looking for text. Forcats is categorical variables and whatnot, a whole bunch of things. But the whole idea here is that, what was I going to say? That ggplot2 was meant or designed to work in conjunction with these other packages, and so it's where we're gonna focus. This is a little bit of editorializing, but honestly, I mean, right now, I think most of the investment and effort is made by people writing packages that interact and share share sort of structure with these Tidyverse programs. So for example, if any of you do anything with time series data, some of the time series packages that have been written have created a new data frame type called a Tibble, Tibble. So it's Tibble with an S for time series. And that works with time series kind of regular, making it integrate with all the Tidyverse stuff. So I think a lot of the, at least near-term future is going to be people making, sort of packages and whatnot that share this Tidyverse kind of setup. So ggplot2, there can be, kind of, what was I going to say? A lot of sort of specification in it, or customization, I should say, in it. But really all graphs, and I'm using graph generically, like histogram, I'm calling a graph, or a scatter plot, I'm calling a graph. So just any picture, maybe picture is maybe not a better word, but is maybe a better word, is going to share three common elements. You're going to have to provide information about the data. You're going to have to provide something about the aesthetics, which we'll look at examples in just a minute, and then geomes. All right, so a really handy thing, and this is posted to the course page, is this data visualization with ggplot cheat sheet. So I didn't create this. You can tell it's very nicely typeset and all that. Someone with a little better marketing design background than me came up with it. But it's a really good place to experiment with some of these things. Obviously, I'm going to show you some code and we're going to walk through some things and you can ask questions. But I'm just pointing you to this resource. Again, I think there's a hyperlink at the bottom of the slides, but there's also the PDF is on the Google Drive, so you can get to it. But you can see it's got kind of all this different information. This may be overwhelming at first, but hopefully will all look a little bit better in just a minute. But I just wanted to point that that's out there. Okay, so let's go and let's actually think about things. So you can see example number one. Suppose that we have a simple data frame with two coordinates, x1 and x2, and a group identifier, which are called group. Okay, so I'm going to toggle over to R and just kind of do some of this stuff live. So you saw that I had this data frame. So I'm going to start by loading packages. Now I could load ggplot2, I could load these things individually. I'm going to be lazy. I'm just going to load the Tidyverse. So I'm going to type library, I could spell, Tidyverse. Okay. And I want you to watch sort of what happens when I hit enter. You can see attaching packages. So it's doing some of the work for me. It's putting in ggplot2, it's putting in Tibble, it's putting in dplyr, it's putting in all those things where we just showed you those nice icons. It's showing these things that are conflicts. So for example, dplyr has a function called filter, and the stats, which is part of the base package of R, also has a command filter. So this is just telling you, hey, dplyr is going to block that old school one from working. Same with lag. That doesn't really matter for our purposes at this exact second, but I just kind of wanted to, point out that that's there. So I'm going to go over here. So I have an R script here where I'm going to type commands. If people find it helpful, I can save these as we go through and post them later. But I'm going to use sort of the read CSV file to read that. I think it was called group data. Yes, group. Couldn't remember whether I used a capital or not. Data.csv. Again, this is the same data set that, or CSV file that is in the Google Drive. So again, you can do this on your own. You see, I ran it, executed over here. Got it. I'll click it open. We can look at it. We toggle back to the slide. You can see it's the same data. Here is just a pasting of what we have. So what we do here is make a basic scatter plot. Okay, so I'll show you the three parts. Okay. So everybody does it a little bit differently. If you look at the cheat sheet, it does it a little bit differently. Um, what was I going to say? So feel free, if you have experience with this, to do it the way you like. There's no main way to do it. But remember the three things that we're going to have. We're going to have, I'm just going to put them here. We're going to have our data, which has to be a data frame or a tibble. We're going to have our aesthetic, and I'm going to be lazy and type AES. Okay, this is things like our coordinate system. Like, what is the X? What is the Y? What should be the Y axis? Things like that. Number 3 is going to be our geome. So basically, like, what type of plot or graph do we want? Okay. So all the plot, no matter what it is, are going to have these 3 elements. Okay. So even though the package is called ggplot2, the function that we're going to have is called ggplot. Okay. And so I'll copy this over. I'll make use of my own copy to clipboard thing, and I'll sort of paste it there, but I'll talk through it. Okay. So if you look at what's happening, you see we have ggplot. Okay. So that's a function. That's the function that's used by the package name ggplot2. I wish they would have, sort of just kept them the same. It does it. So the first thing in my parentheses is df, which is the data frame that I'm going to go ahead and use. Okay, so I only have one thing in my, sort of memory here. But it's going to be our df. Okay, and then number 2, the coordinate system, the aesthetics is you use AES and then parentheses. And so we'll add more things to it in the next couple of examples. Okay. But in there, what you're going to see is I'm saying, here's what to use as the X variable, right, on our plot, whatever it is. We haven't even specified what it is yet. So this could be a histogram. This could be a bar plot. This could be, anyway, it's a line. It could be whatever. We haven't specified that yet, but we're saying, look, when you create this object, the x-axis is going to be defined by the variable x1, just sort of arbitrarily, and the y-axis is going to be defined by the variable x2, again, just sort of arbitrarily. You can change these things. You have the data. You can do the code, see what things look like. All right. And so this line, okay, that line is the first 2 items on our list. It's providing information on the data and the aesthetics. Okay, now, again, we can do more. You're going to see more in just a few minutes. Okay, but for now, that's what we've got. Then we use a plus. So when you add elements to ggplots, you use the plus. All right. And so people will typically do a plus and then write on a next line just to make it clear, because if you can imagine, as you make some really kind of technical graphs, I mean, you can have lots and lots of lines. So organizationally, it's always nice to just start things on a new line. Okay. So what kind of plot do I want here? I want a scatter plot. Okay. I want a scatter plot. That geome, so again, number 3 on the list is geome. Okay. Give me 1 second and I'll come to the question, Juan. That geome is called point. And so if we go back to the cheat sheet, I can drag it over here and I'll come to your question in 1 second, Juan. You can see lots of geomes. So here's, let me pick some ones you might be interested in. Here's geome histogram right here. Okay, here's geome line. Okay, you can see they kind of give you little pictures of some of the things. Okay, and so when we say geome, we mean the ggplot, the data, the aesthetics, plus what is it you want. Okay, and that's what the geom is. Yes, Juan, why don't you?
It's just a very quick question.
Sure.
Does it make any difference at all if I place the AES part of the sort of the stuff that is in the ggplot parentheses outside, like with another plus? Because I've seen that often being
Yeah,
used. Is it just an aesthetic choice, or does
it's
it actually make a
basically an
difference?
aesthetic choice. So let me run this and then I'll show, I'll type it on the sheet, an alternative. So I'm gonna highlight this. Okay, so just highlighting my code. This again, hopefully, I mean, fingers crossed, I don't want anything to go wrong. This should produce the plot that is right here. Okay, I mean, there should not be a big mystery about what's going to happen, but I'm going to hit run. Hooray, it did. Sort of maximize it to make it easier to see there. But you can see it's just a scatter plot. X1 on the x-axis, X2 on the y-axis. Again, you can flip it. You could do whatever you want. That's the same pictures here, other than I expanded it to make it bigger. Okay, so what Juan brought up, and is a really good point, and can be, in my opinion, one of the confusing things about some of this is that there's not one single way to do it. I do things a particular way, but I'm going to show you another way of doing it. So an alternative, and again, I'm not saying it's even the only alternative, but what you could do is you could type ggplot with the empty parentheses. Okay, or let me do this more in line with kind of what was said. I'm only going to provide the data frame. So if you think about my checklist of 3 things, I only have one here, and I add plus. Okay, and now what is it that I'm wanting to do? I'm wanting to make a scatter plot, which I know from my cheat sheet and past experience is geom underscore point, for plotting points. Okay, I can do geom, sorry, point, and you can see just auto-filling like all the geoms that are possible here, which again are all named on the cheat sheet. But I'll go point, I'm sorry. And so what I can do here, so I've, if you again want to think of this as a checklist, I've done number 1 and I've done number 3. I've done the data. I suppose I should add 1, which is like number 0. You have to have ggplot called that function. But that aside, I've got the data and I've got the geom that I want, but I've never provided the aesthetics, the AES. So I could do that here. I'm going to highlight and run. Same picture. Okay. So it's really a matter of personal preference. This is just me. Um, I like to get 1 and 2 kind of done right off the bat. But because that way, if I need to specify some other things later on or what have you, because we'll get into some, I don't say more complicated, but we'll build in some things over time. I like to kind of just do it and say, this is what my plot is. But you can see clearly, same output. It didn't matter. I can even make that blank. Uh, okay, so that didn't let me do that. But I'll show you something. So what was I going to say? So I can use piping to send it. And if you're not familiar with piping, we'll do a little bit with piping in just a few minutes. But I can send the data frame to ggplot. And so I've never even typed it inside the parentheses. So there's lots of options. And again, as Juan's kind of comment said, I mean, a lot of it is somewhat a personal preference of how organizationally you like to do it. Anyway, all of these things work. I'll sort of copy all of these and I'll save this file at some point and upload it if people want. So, okay. All right, so that creates a scatter plot like this. All right, nothing exciting, nothing special going on. but we over time might want to add embellishments. Okay, so again, going back to, oops, I keep dragging it over here. I have two monitors, so I'm dragging one. Okay. So Kristen made a point about it matters when you add additional elements. So so maybe, and maybe this is what Kristen is referring to, you might want to provide the aesthetics with each individual group when you have more items on there and they have their own XY coordinates. That's a good point, and we'll talk about that in just a little bit. But just to paraphrase what she's saying, if you wanted to put 3 lines on, then you don't just have one Y. Okay, they each have their own Y, and so we might want to put them individually. Yes, thank you for that point. Okay, so you can see what I'm going to do, or what I did on the slide, is I added a line. Okay. Geom_smooth, going over here to the cheat sheet, geom smooth. Okay, so you can see here it's curved. You can have different methods. Okay, so notice this is method LM, linear model. Okay, so I'm putting a linear regression, but you can get different things. SE equals false is asking if you want a, what was I going to say? If you want sort of a confidence interval around your line. So let me just run this and then we can use it to explore, okay? So I'm gonna highlight it. So all I did, so again, just the top 2 lines are the same thing, but I'm using a plus here because I'm gonna add an element to my plot. That's what sort of the plus is doing. Like, let's add something to what we have. Let's add something. What we're gonna add here is another geom, which in this case is a fitted line. Okay, so I'm going to highlight all of it and I'll run. Okay. Drag all the way, makes it too exaggerated, but you can see we have this. So look what happens when I could just delete the SE part, but I'm going to turn it to true just to show you. But look what happens when I run it. Now I get the sort of confidence band on there shaded. Okay, so you might want it, you might not want it, depending on what you're doing. But to get rid of it, we do false. Okay, and so that's what we have here. So again, I've added it by using the plus sign to make an addition to our existing plot. Okay. This, I think, is additionally useful. Okay. And you're going to see, we're going to build all of these items in, by the way, to some of the apps in just a little bit. So we will not sort of abandon all cases here. But so, okay, if we go back to my original data, that was a lot. Let me just do head. So we look at the first 10. So I'm using the function head to look at the first, in this case, I've said 10, the first 10 observations in our data frame. Okay, you can see down here in the environment that I have 150 observations. All right, I could ask for that information. I could say, what is the dimension of DF? 150 by 3. But having said that, I can look down there in the environment and see that it's 150. And so either way, so what we're looking at is the first 10. And so in addition to the coordinates, I've intentionally built in a group. Okay, and so you can see the group here, A, B, and C. That's what you can see on the screen. If you weren't sure how many groups there were, there are a variety of ways you could tackle that problem. But one problem you could do is you could type unique data frame, the $ to access the group. And it would say, okay, they are A, B, and C. All right, so there's not a D that's maybe not in the top 10. There would be no problem if there were, except that you can see on the screen, I've picked three colors. So I'm going to run only part of this first. I don't have to, I could just select part of it and run, but I'm going to give the whole thing just to, again, hopefully make it more clear on your screen. I'll clear that. But so what I've done, so if you notice what we have over here, we have the same exact thing we had before, all right, except I've added something to our aesthetic. I've added the color, okay? Or more importantly, I've said, okay, ggplot, when you make this plot, use x1 as your x-axis, use x2 as the vertical or the y-axis, and use the group variable. So notice again, remember that's a name in my data frame. So it's not a reserved word. It's not, oh, set the color equal to a group. It's because my variable that indicates what belongs together is group. In another example, it could be states, right? Like maybe you have some data over different states. And so the quote unquote group there is what state they belong to, or what county they belong to, or what country they belong to, or something. Okay, so then you would have color equals country, or color equals state, or whatever. Okay, here it's a variable name. All right, and so look what happens when I just run that as is. Okay, I get it. It works. All right. It provided the same plot. So I'm clicking back. This obviously has the line. So shield the line from your eyes. Pretend you can't see the line. This data is exactly this data, only we've added the additional element of indicating what group that is. Now, this can be really helpful. So just as an example, I made a dashboard for a consulting project where my client was a law school. It's not confidential, but I'll just leave their identity out. And one of the things I made for them was I made a plot to show them on the x-axis was something like the undergraduate GPA of the applicant, and on the y-axis was the LSAT score. And in that graph scatter, I used for the group whether the student was admitted or not. And so you had something where, you know, I made it dramatic colors to and all that to sort of make it more apparent. But nevertheless, I used the group, and so in that way, even though it's a two-dimensional plot, we're actually indicating maybe 3 dimensions of information. Okay. Nevertheless, you can see what happened is I didn't provide any additional information, and so I got these default colors. This is me, personal preference, right? I like the color blue. I like green. This is sort of a pinkish red. I guess it depends on how my screen looks on your screen. But, you know, it's maybe that red, or again, sort of pinkish, pale red for group A, as, you know, maybe a little faint on the screen. I don't know, maybe the blue's a little, maybe the green, I don't know. Whatever the case is, I wanted to specify my own colors, okay? And so that's what I did here. So again, if you look at this next plot here, and I'm just gonna save this, I'll call this live plots.r. Okay, so I don't know that you need this, but I'll upload when we're done with all the plotting on one of our breaks or at the end of the day, just depending on how quickly we get to things. But you can see what I did. And so I used an additional capability function here called scale color manual. Okay. And so as you can sort of decipher from the terminology here, I'm asking to manually set the color. Okay, manually set the color. All right, and so I do that by specifying values. So values is a restricted word here. It is what you use when you're setting it. You use the values key here or name to set it. And I've chosen just, for no real exciting reason, I've chosen red, blue, and black. You can see I highlight and run that, and I get the same thing. Okay. Maybe that wasn't so great. I'm staring at the plot now, and some of the blues and some of the blacks are a little hard. Maybe it's because I'm getting old and need readers now, but the red and or I'm sorry, not the red, but some of the blue and some of the black maybe are not, looking great, all that. But nevertheless, I mean, you can see how I can set my own colors for the different groups. We will incorporate this. So just kind of like thinking ahead, I'm going to use this example and do things, for example, when we make our shiny dashboard, like allow the user to specify which groups they want to see. Right? Again, if you thought of this as like a real data project, you might want to let your say the user, I mean, the person interacting with your interactive dashboard, I mean, maybe you want to let them pick which states to show the data, or which country, or which county or city, or which company, if it's financial data or something. So we're going to be able to select these things later on. But for now, I've just sort of specified these groups. Okay. All right. All right. So example number 2 is going to be sort of a time series example, which I'm just using to plot, what was I going to say, to show sort of line plots. When I was thinking about the class, and I mean, you don't have to do it right now, but I mean, if someone wants to jump in on the Slack and say, hey, if there's time at the end, it'd be really fun to see, I don't know, some other type of data or whatever, I can look at it. But when I was thinking about, hey, what are some of the most common things that I would, when I click through and look at dashboards or play around with dashboards I find online, I mean, lots of them are scatters. Like pick what you want on the X, pick what you want on the Y, pick which groups or states or countries and play around with that. Those I find lots of, show me the budget versus the revenue for different companies or something. I find lots of scatters where you change who you're showing or what the axes are showing. And I find obviously lots of like line charts. What does the revenue over time look like? What do subscribers over time look like? What do things like that? And so those are what I picked. If someone's got something really exciting, I'm happy to try and incorporate a different example, near the end of our course, if you want to just throw that in the Slack at some point. But just having said that, next thing we're going to look at is a line. We're not done after this in terms of, thinking about plots, but I just want to give us sort of a basic plot that will over time incorporate more into as we incorporate additional elements. One thing I want to point out that's, you may know, I mean, we sort of live in a time, or at least if you're like me, you're like, how do I, scratching your head, how do I do that? And you sort of turn to Google. But one thing I want to point out is that for some of these things, particularly with ggplot or the geomes themselves, I mean, the help that you can access directly within RStudio is actually quite, in my opinion, quite helpful. So if you've never done this, so you thought, I want to make a histogram. So a histogram is geom_histogram. Okay. And it's not super cleverly named. You can see it right here. Sorry, my mouse is quirking there, but you can see here. So I think, oh gosh, how do I do that? How do I go ahead and make that? Or what are the things I need to set? Or what are the different things I can change or what have you? A really handy thing to do, other than look at the cheat sheet, or if we're during the class, you can ask me, but a really handy thing to do is type help and then in parentheses with quotes around it, type the function that you're looking to have help about. So maybe I want geome histogram. All right, so I'm just going to type that, and I'm going to hit enter, and it's going to pop up a window from the bottom. I'm going to kind of expand it up, but you can see sort of like lots of the options that you have. Okay, like, oh, bin width, bins, what do you do? So NARM is, sort of how do you handle NA values, missing values. You can see reading arguments about it. But what's even sometimes more helpful is to look at the bottom, okay, where they have some examples. And so you've got, oh, here you can see I set the bin width at 0.01. Here, in this example, they're specifying the number of bins. So all of these ggplot items or functions, these geomes, they all have these help menus that you can see. So not only that, just in terms of exploring, let me drag back our cheat sheet here real quickly. But what you see is on a bunch of these examples, they give you some syntax. So ggplot economics, date unemployment, ggplot diamonds, with the aesthetics being carat and price, and so on. MPG, with the aesthetics being city and highway, okay, that they then use in these plots. Well, the nice thing about ggplot is that they've built in a bunch of, what was I going to say? A bunch of these data sets that you can use. So everything on that cheat sheet you can do without loading anything other than ggplot2. So you can do all the examples that are in there. You don't need, oh, well, I'd really like to play around with histogram, but I don't actually have any data that would work with a histogram. You can use the data that they have built in for that, okay, which is the MPG data set. Okay, so just again, I encourage you, obviously, throw some questions into the Slack, later on if you experiment with any of that. But I just want to point out one of the really nice things about the authors of ggplot2 is they've made it really easy by including some built-in data sets and by having this sort of cheat sheet. They make it really easy for you to experiment and play around without needing, say, your own data. Now, obviously, it's more fun or whatever to experiment with your own data, but you might try both, just to kind of see what you want. Okay, so moving on to example 2, which is a time series thing. Okay, so if we go, I'm just going to put, so I'm just going to do a little organizational here. I'm going to cut that at the top. I did library tidyverse. For completeness, I'm going to put that in there. All right. This was example number 1. Go down here, example number 2. And like I said, I'm not saying you necessarily need this file because, you can sort of click on the code and all that. But having said that, since I'm typing it, might as well save it, might as well put it up for you. So I'll be doing that. So if you go again into my directory here, oops, I have this time series R data. Okay, that is up again in the Google Drive. So I'm just going to load that. So I'm going to forget everything I have to just focus on this one. So you see run, notice I had this emptied, and notice when I loaded it, it created this data frame. Okay, you can see I've got time, I've got a series, I've got values. All right, and so just kind of scrolling through, again, this is the same data here. You're just looking, you can see the head, you're just looking at the top 6 here. But in this, I have 3 series. So I have the month, which obviously is going to be the time. As forecasting ahead here, you can imagine that this is what I'm going to use on my x-axis, okay? And then the series value, I'll have 3 series. I have unemployment, I have the federal funds rate, and I have the CPI, the Consumer Price Index. Okay, doesn't really matter what they are. I downloaded, these are real data. I downloaded from the St. Louis Federal Reserve. That doesn't really matter because we're not going to do anything useful in terms of economics with it. But I just wanted to show you, if you wanted to know the names, again, we could do unique, TSDF, and then the series, because again, you can see that is what I call that. And you can see I get unemployment, Fed funds, and CPI. Okay. While not strictly required, sometimes, what was I going to say? Line plots with multiple different series. Sometimes it's just handier to create them as what you saw, which is a long format. Okay, long format data as opposed to wide format. So for example, a wide format data might have the first column be the time, and then the second column is the value of unemployment, and the third column is the value of the Fed funds, and the fourth column is the value of the CPI. There's nothing wrong with that. You can create that. I have lots of data that appears that way. The one advantage that sort of authors of these packages cite about making it long, so notice it's stacked on top of each other, is you can just say, for example, thinking ahead, right? Because we're thinking ahead. We're thinking about building these interactive dashboards. Okay, so we're gonna, the whole idea of interactivity is we're gonna want the user to be able to select things, right? Maybe select the time periods that they view, or select which series they view, or things of that nature. So thinking ahead to interactivity, it's going to be easier for us to incorporate interactivity in a long format because we can say, hey, the user wants the series equal funds and the series equal CPI. And so it's just easy to slice that single variable series instead of dealing with, well, if this, then take that column. If this, then take that column. Both will work. There's nothing wrong with the other way. I'm just saying this was chosen to do this way for the purposes of, in the future, building in this interactivity. Okay. So we've got that time series, okay, that you see here. All right. And we can think about plotting one. So let's start with that. All right. So before we do that, we rewind a little bit to the capabilities of dplyr. So it's all lowercase, but well, actually, I don't want to confuse myself, put dplyr. Okay. So dplyr is the part of the Tidyverse that's really handy for the manipulation of your data. Okay. And so there are a number of features, what was I going to say, in the data there. Sorry. That we might want to think about. Okay. And so dplyr has lots of capabilities. We'll explore some later on. But for our purposes, 2 really useful functions in dplyr are filter and select. Filter limits the observations that you have. Maybe we want to filter, only give me those values that are bigger than 10, or, you know, of something. Obviously, that's not a good example for this time series data, but I'm just saying, you may say, hey, you know, pull out the people in my health data set that weigh over 250 pounds. That would be something that would be accomplished with filter. Okay. Or show me people who, you know, pull out only those observations from my data where they earn income less than, you know, $50,000 a year. or whatever, the value may be. Filter is what's really useful for that. Okay. Filter, again, preview of coming attractions. Filter is going to be really helpful for us when we think about interactivity, because it's going to help us say, hey, the user is saying that they only want to see A, B, and C, not everything in the data. So let me use filter to filter out A, B, and C and only pull those things. So the way dplyr works is through piping. Now there are different piping. Okay, so I'm just going to dplyr and put quotes, piping. There are different types of piping, but what I'm going to use, because everything I do only requires this particular type of piping, is going to be the %sign. It is one of the greater than or equal to. It's the one that points to the right. And then the $sign. I'm sorry, the $sign, the %sign. Okay. What that does is it takes something from the left. It's probably be reversed on your screen. Takes something from the left and pipes it to the right. That's what the piping does. Okay, so it passes it along to an end product. So for example, this could be helpful when you don't want to save intermediate steps or have to keep creating new variable names or do things. Again, just to make sure that this is clear, I mean, most of the purpose of this for us is going to be when we start thinking about interactivity, all right, and having our users supply certain things or select things, right? You might imagine like a drop-down menu, like, hey, pick which state you want to show, or hey, pick which one of these Y variables you want us to show. I mean, we're going to be building in this interactivity. So we're going to be thinking about things like filtering our entire data to just pull out the things that we want, as an example. Okay, so the way it works, and again, going back to Juan's question about the ggplot, is there's not one single way to do this. You may find other ways. This is how I do it for whatever it's worth. Okay, so we're going to start by saying, where do we want to start? And in our case, we're going to start with our time series data frame, which you can see down here in the environment is ts_df. So ts_df. Then I'm going to use the piping. So you see, I just did the piping. Now, you don't have to. Again, this is under the umbrella of you see all kinds of different things, but I'm going to use the piping and I'm going to send it on a new line. Again, just for clarity, not saying I couldn't combine these things. Just like the ggplot, I could combine multiple things onto one line, organizationally, visually, helping me keep track of things I like more than one. Okay, so I'm going to take tsdf. All right, and just in our example, so notice we have, going back here, we've got several different things for our series. Okay, so we've got unemployment, Fed funds, CPI. Maybe I only want to pull out the variable or the observations that correspond to the CPI. So I can do that using filter. So I'm going to type filter. And you notice you don't have to worry about the yellow kind of help information, but notice on the screen how it's sort of auto-populating, oh, filter from dplyr. That's what it's showing in the sort of curly brackets there at the end of the blue highlighted line. It's saying filter from dplyr. We don't need to worry about that, but I'm just saying that that's where that's coming from. Okay. And so here we're just going to use sort of logical, what was I going to say? Sort of logical statements here. So I'm going to want to pull out those observations where the value of series is equal to CPI. So I'm going to type series. And again, notice how helpful it is. It's sort of auto-filling. So if I want to get lazy or I'm worried about spelling or something, I can just hit enter here and it's going to auto-fill. Notice I was about to point at my screen, but that doesn't help you. Notice it says series and then in square brackets TSDF, telling you that that's a variable in there. Notice if I put value because that's the third column of that. It's saying, oh, value from TSDF. Okay, so I'm going to put series. Because this is a logical, we want the double equal sign, okay? One equal sign, it thinks you're trying to assign it a value here, but no, we're testing. All right, I want you to filter where the series is equal to CPI. Okay, so I'm just going to highlight this. And I'm going to run. And what you're going to see, because I didn't assign it a new variable name or I didn't assign it into a new object of any type, it's just going to print to the screen. So I'm going to type run. And now it's only showing me the first bit. It's saying, gosh, you probably don't want to see, now this is not a big data set, right? But theoretically, maybe there would be like thousands and thousands. We're not going to print thousands and thousands. We're going to limit it. So you notice they're giving you the first 10 rows and telling you that there's 279. Okay. But again, what do you see? You see the month, time, you see the series, which was CPI, and then you see those values. Okay. If we wanted to assign this new set of observations, this new data to a new object, I could do that two ways. Again, so sorry to pick on Juan asking a great question, but this goes back to a little bit. You're going to see it both ways. I'm telling you now, this is being recorded. You can go back and look at it later. Either one is fine. Either works the same. It's personal preference. So one option that you can do is you can add an arrow. Okay, so it's sort of the minus sign or the dash followed by the greater than or equal sign that points to the right. And I can give it a new name, if you will. So maybe I would call this like the CPI DF. This has nothing to do with the course. I tend to call things DF or data frame. So this is like CPI data frame. So notice what happens. I'm going to clear my screen here over here on the right-hand side. I'm going to highlight this and run. And so look down here in the environment. We only have data as TSDF. Looking here, we have nothing. I'm going to hit run. So now it showed me the commands that were executed, but I've now created a new data item in here. Okay. So that's one way of doing it. All right. Using that assignment operator, or you could do it the other way. You could type CPI DF and assign the whole thing that we just did. Okay, I'll execute it just for fun, but you'll see that there's nothing different. 289 observations of 3 variables. It's going to have the same name. It's just going to write over what we did before. Okay, that's what you get. All right. So both of these work for reasons that are basically kind of like historical to more of a computer programming commentary than it is a data science or data visualization conversation. But it's basically, you know, if you look, R does work with the equal sign. Lots of things work using the equal sign in R. But kind of like the old school, the examples you all see, they all use, you know, this thing. And it's not like, oh, R uses that as an equal sign. R doesn't use that as an equal sign. What you're saying is this is an assignment operator. Take this thing and push it over to the left. It's a left arrow assignment. So this is just the opposite. It's taking that and pushing it to the right, and it's a right assignment operator. Okay, but both give you the same exact thing. Okay. So where this comes into play in the slides that we have is if you look at the plot, here I've just said, hey, show me the plot for unemployment. All right, and so again, I'm going to be kind of harnessing my own built-in shortcut here, and I'm going to copy to the clipboard. All right, go back here, and I will paste. All right, and we can sort of decompose what's going on. So I'm taking my time series data frame. And again, maybe to be consistent with what I've typed here, I should have done it. To be honest, I was just trying to make things fit aesthetically pleasing on the slide. So I have my first, sort of piping and then the function on the same line. Obviously up above, I broke it up. It doesn't matter. I did it on the slide this way, again, just to make that box as small as possible so the plot would fit nicely. This is a side note. I used Quarto, Quarto, to make these reveal JavaScript slides. I love it. It's great. Works really well with R. Works really well with R code. Highly recommend it. I don't get paid by Quarto to advertise that. They don't pay at all. So free advice. But anyway, I wanted to make the code, this clickable code, smaller so I can make the plot big enough. So that's what was happening there. In any case, but you can see, so I took that, I piped it to the filter function where I pulled out only unemployment. Okay, again, in the example I just did, I pulled out only CPI. Then I piped it to ggplot. So notice, kind of going up to above, I erased it. Oh, no, I didn't erase it. Notice here, I took the data frame and I piped it to ggplot. I took it and I sent it to whatever is on the right. What was on the right happened to be the function ggplot. That's the same thing here. So if you're thinking about things, again, like moving ahead, because in the back of your mind, we're not just learning this for fun, and some of you probably have experience in this. We're not just learning this for fun. We're learning this so that we can use this in our interactive dashboards. Okay. And so one of the advantages of this piping, this sort of piping system that we're using dplyr, is I don't have to save a brand new data set. All right. So notice I did, just as a demonstration purpose, but I created this new file called CPI. But when we're doing these things, we may not want to just keep, quote unquote, making exponentially more data frames the user selects one option and we create a whole new data set and that's stored in the memory and then we plot it. And then they click something else and we create a whole new, and now they've clicked 20 times and we have 20 new temporary data frames. We probably don't want to be clogging up our sort of server's resources, even if it's Shiny apps or if it's your company's, or if you build your own R Shiny server, which I talk about very briefly at the very end of the course. You're not going to want to have all that. So one of the advantages here is, notice I'm taking the time series data frame, I'm filtering out or pulling out the unemployment, and then I'm sending that to ggplot. So if you look at the lines that are ggplot, okay, if you look at the lines that are ggplot, there's no data frame. Okay, it inherited the data frame from the piping. The same way up here, I never specified the data frame. ggplot inherited the data frame from the piping. So I've done it. I've pulled out only the unemployment series, but I didn't waste computer resources creating a brand new file.